Hello everyone, I welcome you all to Benju's Education, your one-stop destination to prepare for GMAT, GRE and SCT exam. So we have already covered up the basics of probability and permutation and combination, where I have already uploaded videos from the basics of probability, permutation, combination, and then we have also solved questions related to those basic concepts, right? Now, the motive of preparing this video is to make you understand how to solve difficult level of questions or the advanced level questions of PnC and probability. So I have taken up a total of 10 questions. So I believe I'll have to make two videos on this because the level of difficulty is high and I'll be requiring more amount of time to explain you how to solve these typical questions. But the questions are actually of good level. If you are preparing for GMAT, then these questions will come to you if you're aiming for 700 and above. And in case of GRE, if you score good in the first section, then you are bound to get questions like these. Not exactly the same questions, but on the similar lines, the concepts on the similar lines. Okay. So we are simply doing advanced question. I will not be teaching you any basics of probability or PnC in this video. So if this is the first video that you're watching on probability or PnC, then I would suggest you to go through the basics of probability and PnC. You can simply type Benji's Education, SAT plus GMAT plus GRE, and then go to the playlist. And from the playlist, you can watch the basics of probability and PnC, right? And then you can come back here because in this we are simply going to discuss questions and nothing else. Okay, now what we're going to do in this video is that I'm going to show you a question on the screen. You're going to pause the video and you will try that for yourself. The questions are good and I want you guys to try these questions first before you understand how to approach a particular question. Okay, and we have mixed questions, probability, some from probability, some from PnC. Okay, I may not also follow the order. Probably you will see question number 1 and then I'll go to question number 3 and so on and so forth. But we're gonna solve all the 10 questions, and I have taken up one data sufficiency question also in this because that question, I like that question, and it will actually help you in understanding the concepts of PnC and probability. All right. Okay, then without wasting your much time, let's move on. So pause the video and try this question, please. Very good question. Try this question. All right, let's see how we can solve this one. So let's see what the question says. You have a bag of 9 letters, 3 X's, 3 Y's and 3 Z's. You are given a box divided into 3 rows and 3 columns for a total of 9 areas. Okay, so we have a box. So this box is divided into 3 rows and 3 columns. So I'm gonna have something like this. And this is to be filled with 3 X's, 3 Y's and 3 Z's. And that is given to me in the question. So I have to fill them with 3 X's, 3 Y's and 3 Z. How many different ways can you place one letter into each area such that no rows or no columns with 2 or more of the same letter? Now first of all, let's understand what do we mean by this condition given to us. That is no rows or columns with two or more of the same letters. That is, if you write if you try to fill in your grid something as xx y z y z, this is incorrect. You can't have you can't have two x's in the same row. You can't have two z's in the same row. This is incorrect. Or let's suppose if you write your third y here, and let's say the x's were not here, I'm simply filling up y, I'm not filling up x and z. Now this is again incorrect because the two y's cannot be in the same column also. So no two x's, no two y's, no two z's in the same row, no two x's, no two y's and no two z's in the same column. That's the concept. No two x's, no two y's, and no two z's in the same row. No two x's, no two y's, and no two z's in the same column. Now we have to fill in these 9 spaces with x, y, and z using the condition. So the question is, in how many ways can you do that? Let's see what we can do with this one. I'm going to start with x. I'm going to start filling with x. So start filling with x. You can start with y, you can start with z also. Now let's go row wise. You can also go column wise, but for the convenience, I'm comfortable with row wise, so I'm going to go with row wise. Now what's going to happen? Now if I start with, this is first row, second row, third row. This is first column, second column, and third column. Now if I talk about the first row, there is no condition. I simply have to place in x. So I can say x can be placed in any of the 3 positions, because I don't have to worry about second row, I don't have to worry about third row, because I'm starting with the first row. So the first x, the x which is supposed to come in the first row, can be in the 1 1, that is first row first column. It can be in 2 1 second column first row. It can be the 3 1, or whatever way you want to name it. So basically the first row, which is the first x which is to be placed in the first row, can be placed in 3 different ways, and the total number of ways will basically be 3c1. So the x that is to be placed in first row can be placed in 3c1 ways, or you can simply write 3 ways, whichever way you want to write it. Now the x that you're going to place in the first row will either occupy the 1 1 position, 1 2 position, or 1 3 position. It will occupy one of the 3 positions, which means the next x that you will be placing in, will have only 2 options. Because let's say suppose if I place x here, then in these 2 places x cannot come. Or let's suppose if I place my x here, and that is in the first row and second column, then the 2 x's cannot come in these 2 positions. Or if I place x here, then the 2 x's cannot come at these 2 positions. So if I look row wise, so for the first row, x can come at any of the 3 positions. The second x, which has to come in the second row, cannot come at a position directly below the position in which the x in the first row has been placed. That's the whole point. So if you talk about the second row, the x has 2 options, so that is simply 2c1. It cannot come directly below the x placed in the first row, but in the remaining 2 positions the second x can come, or you can simply say 2 ways. Now for the third row, or for the third x, you will have only one option left. So for example, let's suppose if x was placed in the first row, it was in the second column, second row it was in the third column, so the only option with x is the first column of third row. X does not have any other possibility. Now we are done with x's. So if we started filling with x, we can say the number of ways in which we can fill x is basically 6. That is 3 into 2 into 1, because we need all the 3 x's. So we will have a total number of 6 possibilities. Now let's see what we can do with y and z. Let's start with y. Now I'm gonna go ahead with this case, that is x here, and x here. Now whatever number of ways of arranging or distributing y and z comes out to be, I'm gonna simply multiply it by 6, because that represents the total number of ways of arranging x's. Okay, I'm gonna simply do that. Let's start with y. Now what all can happen with y? So if we talk about the first row, now I'm removing this because I probably need to draw a couple of more grids. So let's have one more grid. and we're gonna have x, x and x. Now let's start filling in y. So if we talk about the first row, y can come at this position or y can come at this position. These are the only two possibilities that I can have with y. Now what about the second position? Sorry, my bad. What about the second row? So this is my case number 1 and this is my case number 2. Now for case number 1, y cannot come here. This is not a possibility for y, right? Because it cannot be directly below the above y, so this is not a possibility. And at the third position we already have an x. This is already here, which means there is only one place for y to be, and that is in the middle position. That is in the middle position, which means for the third y there is only one position, and that is this position. We cannot place y anywhere else. This is the only setup that we can have. This is the only possibility that we can have as far as case 1 is concerned, which leaves us only one position for z also, which leaves us with only one position for z also. So there is only one case. That means there are only 6 possibilities as far as case 1 is concerned, and those 6 possibilities are because of the placements of x's. Now let's come to the second case. So we have y here at the third place in the first row, which means I will have y at 2 more places. I can have y here. This is a possibility. And I'll have to draw one more grid. Now x, 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 and y is already here. This is another place where y can be. Okay. Now let's come to the third row. Now for this case number 2, the only available place for the y in the third row is the middle position, because y cannot be directly under the other two y's. So this is the only possibility. Whereas if you talk about case number 3, I don't have any position available for y, because y cannot come at this position. It's not possible because already a y is here in the same column, and y cannot come at this position also because already a y is here. So this case is already out. And in this case, these y's will have their fixed positions. I cannot take this y here. It's not possible. Which leaves us only one position for z in each of the 3 rows or in each of the 3 columns. So again, this will give me a total of 6 possibilities. Case 2 will also give me a total of 6 possibilities, and that is because of the rearrangement of x's. So 6 possibilities from case 1, 6 possibilities from case 2, which will give us a total of 12 possibilities. So how many different ways in which we can place one letter into each area such that no 2 rows or columns with 2 or more of the same letter? Your answer is simply 12. Your answer is simply 12. That's it. Okay, now this is the question where the basics of P and C does not help us, right? You'll have to manually see what all possibilities are there. These are the types of questions where counting method helps us more rather than doing NCR or NPR. Okay. All right, let's move on. Before moving on to question number 2, which is our data sufficiency question, I would want you to solve question number 4, please. Pause the video and try this question, please. All right, let's see how we can solve this question. So Kate and Denny each have $10 Together they flip a fair coin 5 times, alright? Every time coins land on heads, Kate gives Danny $1. Okay, so if it is heads, so Kate will give Danny $1. Okay. Every time the coin lands on tails, so every time it's tails at the top face, so Danny gives Kate $1. Okay. After the 5 coin flips, okay, so coin has been flipped 5 times. What is the probability that Kate has more than $10? So we want Kate to have more than $10 but less than $15. But less than $15. Okay, this is the question. Okay, that's quite interesting. Now, we need to understand how we can solve this question. So let's say suppose they toss the coin for the first time and they get a tail. Now we are concerned with what will Kate have. So head means -1. I'm going to simply write -1. Head means -1 for Kate and tail means +1 for Kate. Now we want Kate to have more than 10 but less than 15. That means we want Kate to gain something rather than losing something. We don't want, like, when these two guys are done with flipping the coin for 5 times, Kate should come out on the top as someone who has won the game, if we consider this as the game, rather than someone who has lost the game, because the result cannot be a drawn. That is, after 5 flippings, it will not be possible that the Kate and Danny go back with the same amount of money. It's not possible because the number of flippings in this case is basically odd. So one of them will obviously have more number of flips. Sorry, my bad. One of them is gonna win more in comparison to the other person, right? If it would have been like 6 flips, then there would have been a possibility that Kate won 3 number of times and Danny also won 3 number of times. But since it's an odd number of flips, so either one of them will have more number of wins and either one of them will have more number of losses. It can't be equal. We will not have a stalemate situation. Okay. Okay, so heads will give -1 and tails will give +1, and we want Kate to have more than 10, which means we want at least 3 tails. We want at least 3 tails. Now, if you're flipping a coin for 5 times, if you're flipping a coin, so let's say we have flip 1, we have flip 2, we have flip 3, we have flip 4, and we have flip 5. Every flip will give me 2 possibilities. Either I can have head on the top face or I can have tail on the top face. So 2, 2, 2, 2 and 2. Now this is basically gonna give me a total of 32 cases. This will give me a total of 32 cases. Every flip will give me 2 possibilities. We will have a total of 32 possible cases. Now, I want tails to be more than heads. I want the number of tails, I want those cases where the number of tails is more than number of heads. That is, I can have 3 tails, 2 heads, I can have 4 tail, 1 head, and I can have 5 tails, 0 head. Now, since 32 are the total number of cases and there will not be any such case, since we are flipping the coin for 5 times, that is the odd number of times, there will not be any such case where the number of heads or number of tails are equal. It's not possible. You can have 3 tails, 2 heads, or 3 heads, 2 tails, 4 heads, 1 tail, 1 head, 4 tails, and so on and so forth. Can I conclude two things from here? One is, for half the cases, the number of heads on the top face will be more than number of tails. That's one thing for sure. And for the remaining half of the cases, you can say that the number of tails will be more than number of heads. Because you're going to get symmetrical number of cases for both of them, right? For half the cases you will have more number of heads, and for half the cases you will have more number of tails, my bad. Now what will happen in this case is, because since we want the number of tails to be greater than number of heads, because that's the way Kate is going to win every time. So what's going to happen is, you will think, okay, we have a total of 32 cases, which means for 16 cases number of heads is more than number of tails, and for the remaining 16 cases number of tails is more than number of heads. So we will simply mark our answer as 16 upon 32, which is 1 by 2, and that will probably be the one of the options. But this is incorrect. This is incorrect. Read the question carefully. You are very, very, very close. You're conceptually, you are correct, but your answer is still incorrect. There is one small thing on which we missed out, and that is, Kate will have an amount which is less than $15. Which means when the coin was flipped 5 times, if all the 5 were tails, she will end up getting $15. $1 for every tail on the top face. $1 for every tail on the top face. Which means out of these 16 cases where the number of tails is more than number of heads, you have to discard one case, exactly one case. And that is when all of them are showing tails. So we will have 15 cases left where the number of tails is more than number of heads, and not all of the tosses are showing tails. So your probability that Kate will have more than 10 but less than 15 will be 15 by 32. It will be 15 by 32, and that is your answer. This question was not about who is winning how many number of times. This question is simply about flipping of coins. That's it, nothing else. All right, let's move on to question number 5. Pause the video and try this question, please. Another interesting question. All right, let's see what we can do with this one. So there are 5 different travelers who each have a choice of vacationing at one of the n different destinations. What is the probability that all Y travelers will end up vacationing at the same destination? There are Y different travelers who each have a choice of vacationing at one of the n different destinations. What is the probability that all Y travelers will end up vacationing at the same destination? Now, let's for a moment, rather than using Y and N's, let's just make this question a bit simpler. And let's say there are 6 different travelers, each have a choice of vacationing at three different destinations, or rather than three, let's say they have three options. One is Paris, another is Rome, and another is New Delhi. So these six different travelers, they have a choice of vacationing at these three places. What is the probability that all six travelers, there shouldn't be an apostrophe here, all six travelers will end up vacationing at the same destination? So they will end up in the same destination. That's the question. Now, let's first understand this question from individual perspective. So we have six different travelers. Let's name them to be A, B, C, D, E, and F. These are my six different travelers. And they all have three options. One is Paris, another is Rome, another is New Delhi. So how many possibilities are there as far as their vacationing choice or their choice of vacationing is concerned? Now, A can go to any of the three places. He can go to Paris, he can go to Rome, he can go to New Delhi. Same thing goes with B. B can go to Paris, B can go to Rome, B can go to New Delhi. And same thing goes with C, same thing goes with D. So if I talk about the total number of options or total number of possibilities, so I can simply say for A it's 3, B it's 3, C it's 3, and so on and so forth, and this will happen 6 times or no. This again like flipping a coin. If you're flipping two coins, there are two possibilities for first coin. There are again two possibilities for the second coin. So your total number of cases will become 2 into 2 in that case. So in this case, it will become 3 into 3 into 3 for 6 times. So as far as total possibilities are concerned, we can simply say it will be 3 to the power 6. It will be 3 to the power 6. Now if we use this concept, and if we don't take 6 and 3, if we simply say I have y different travelers, and each of them has n different destinations, vacationing at one of the n different destinations, so we can say that these y travelers, each one of them have n choices. So for first one it will be n, second traveler it will be n, third traveler it will be n, and so on and so forth. So we will have a total of y travelers. So I'm going to multiply this n y number of times. So my total possibilities will automatically become n to the power y, because I'm multiplying n y number of times, so it will automatically become n to the power y. Now what's the question? What is the probability that all y travelers will end up vacationing at the same place? Now before we solve this n and y question, let's come back to that question: Paris, Rome, and New Delhi. What is the possibility that all these six travelers will end up vacationing at one of the three destinations or at the same destination? Now, if I talk about the same destination, can I say there are only three possibilities that I can have? One is all six of them end up being in Paris, all six of them end up being in Rome, and all six of them end up being in New Delhi. These are the only three possibilities that I have, because all of them have to land at the same place. So the total number of possibilities or total number of favorable outcomes will basically be equal to total number of different cities. Now in this case, I have three different cities: Paris, Rome, and New Delhi. So my favorable outcomes, for the first case, my favorable outcomes will be equal to 3, and hence my probability will be equal to 3 divided by 3 to the power 6, which is 1 over 3 to the power 5. Now if I use this concept for this actual question when why different travelers and n different destinations. Now the point here is that if I have n different destinations, so it may happen that all y of them will go to the first destination, or all y of them will go to the second destination, then all y of them will go to the third destination, and so on and so forth. All y of them will go to the nth destination, which means we're gonna have a total of, if I talk about the favorable outcomes for my actual question, we're gonna have a total of n different favorable possibilities of n different favorable outcomes, and hence my probability will become n divided by n to the power y. N divided by n to the power y. Now this has to be rewritten, and this will become, if this is n by n to the power y, so this is this is 1 divided by n to the power y into n to the power minus 1, and this is equal to 1 divided by n to the power y minus 1. This will be my probability. Okay, you could have done it the other way around also. You could have taken n to the power y to the numerator, and then in that case that would have become n to the power 1 minus y. Okay, either way you could have done it. That's basic concepts of exponents. So this was the concept. All right, let's move on to the next question now. Pause the video and draw this question, please. Okay, let's see what this question says. Bill and Jane play a simple game involving two fair dice, each of which has 6 sides. So we have two fair dice, 6 sides numbered from 1 to 6. With an equal chance of landing on any side, Bill rolls the dice and his score is the total of 2 dice. Okay. Jane then rolls the dice and her score is the total of her 2 dice. If Jane's score is higher than Bill, she wins the game. What is the probability that Jane will win the game? Okay. Now, if you are rolling 2 dices, what all can happen? You can have 2 as your outcome. You can have 3 as your outcome, 4 as your outcome, 5 as your outcome, 6 as your outcome, 7 as your outcome, 8 as your outcome, 9 as your outcome, 10 as your outcome, 11 as your outcome, and 12 as your outcome. These are the only possibilities. So let me write them, because I'll be writing the probabilities also. So let me just quickly write them as 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. These are my possible outcomes. Now, how can I get 2? Now, why do we need this? You'll start understanding this. Because Jane wants to score higher than Bill. Now, Jane can score higher than Bill in many ways. For example, if Bill rolls the 2 dices and let's suppose Bill ended up getting 1 and 1, so Bill will get 2. In that case, Jane can get 3, 4, 5, 6, 7, 8, 9, 10. It may also happen that when Bill rolled, he got 8. In that case, Jane can get 9, 10, 11, 12. A lot of possible cases. So first, let's understand that for individual possibilities or for individual outcomes, what is the probability? So if we are getting 2 as our outcome, then as far as 2 is concerned, there is only one possibility. That is, you will have 1 and 1. That's the only possibility, that you need 1 on the first dice, you also need 1 on the second dice. So it will be 1 by 6 into 1 by 6, that is 1 by 36. So the probability that we'll get sum as 2 is 1 by 36. What about 3? I can have 3 from 1 to and 2 1. I can have from 1 to and 2 1. So two possibilities. So probability will become 2 by 36. What about 4? 4 will be 2 2, 1 3, 3 1. So that is 3 by 36. What about 5? 1 4, 4 1, 2 3 and 3 2. That is 4 possibilities. Or probability will be 4 by 36. Then for 6 it will be 5 by 36. Then for 7 it will be 6 by 36. Now 7 has the maximum probability. 7, the number 7 has the maximum probability. It basically increases from 2 to 7, and then after 7 it starts decreasing. For example, if you talk about 8, so for 8 we can have 2 6, 6 2, you can have 3 5, 5 3, and you can have 4 4. So this is again 5 by 36. Then 9 will automatically become 4 by 36. You can validate the answer also. 4 5, 5 4, 3 6, 6 3. Then this will be 3 by 36. Then this will be 2 by 36, and this will be 1 by 36. You can add the numbers also. 1 plus 2 plus 3 plus 4 plus 5 is 15. So you have 1 to 5 on left side of 6, 1 to 5 on right side of 6. 15 plus 15 is 30, and 6 by 36, the 6 of that probability of getting a sum as 7 on the top face. So you will have 6 from there also. That will be 36 by 36, which is 1. Now let's start to understand this question. Now it's not possible for us to break this question into different cases and then solve for it. This is not feasible. It's not at all possible. We can't say, okay, let's consider a case when Bill will score 2 and Jane can score 3 4 5 6 7 8 9 10. Let's say a case where Bill will score 3 and Jane will score 4 5 6 7 8 9. There will be a lot of cases like this. I can't take care of all of those cases. It's not possible for me because I have this time pressure. So if I think about this question, can I say there are 3 possibilities? When these two guys are going to roll the 2 dice, there are basically 3 possibilities. One is Jane's score is higher than Bill's score. Second is Jane's score is equivalent to Bill's score. And third is Jane's score is lower than Bill's score. In actual, these are the only 3 possibilities. It may happen that the score is a tie. Who says that if Jane is scoring 7, if the sum is 7, then Bill can't score 7? Bill can definitely score 7. Bill can definitely, very well, Bill can score 7. Right? Now, what we will do is, so I can say that Jane scoring more than Bill, or let me put it in this way, probability that Jane will score more than Bill plus probability that Jane will score equivalent to Bill plus probability that Jane will score lesser than Bill should be equal to 1. Because these are the only 3 possibilities. Nothing else can happen. These are the only 3 possibilities. That's it. So I can say that probability that Jane scores higher than Bill plus probability that Jane score lower than Bill will be equal to 1 minus when both of them scores equal. Now let's think about these 2 conditions for a second. Or let's think about these 2 probabilities for 1 second. Can I say that probability, or let's put it in this way, the total number of cases where Jane will score more than Bill should be equal to probability when Jane will score less than Bill? Think about this. If Jane gets 2, then Bill can get 3 4 5 6 7 8 9 10 11 12. If Bill gets 2, then Jane has a chance of getting 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If Bill gets 3, then Jane can get any number from 4 to 12. But if Jane gets 3, then Bill also has a chance of getting any number from 4 to 12. So both of them are basically countering each other, right? They both will have equal probabilities of losing or winning from each other. So if these two are equal, I can simply say that 2x should be equal to 1 minus probability when they both will score equal score, and x, that whether Jane wins from Bill or whether Jane loses to Bill, will be 1 minus probability when Jane scored equal to Bill divided by 2. This should be my answer. Now I just need to calculate the probability when they both will have the same score. So if they both score 2, then it will be 1 by 36 into 1 by 36. If they both scored 3, it will be 2 by 36 into 2 by 36. If they both score 4, it will be 3 by 36 into 3 by 36. And so on and so forth up till 5 by 36 into 5 by 36. Now these probabilities I can simply multiply by 2, because the probabilities that will come for the numbers on the left of 7 will exactly be equal to probabilities of the number which are on the right of 7. We are only concerned with probabilities, and we can say that the probability of getting a sum as 2 is equal to probability of the sum equal to 12. Both of them are 1 by 36. I can simply multiply this by 2. And I'm going to add to this, I'm going to simply add 6 by 36. That is the probability of getting the number 7 on the top face into 6 by 36 for both of them. So let me remove this because I need some space. I don't need this. Everyone have understood this concept. So this becomes 2 into 1 plus 4 plus 9 plus 16 plus 25 by 1296 plus 36 by 1296. So 1, 4, 10, 14. 14 and 16 is 30. 30 and 25 is 55. 55 into 2 is 110. 110 and 36. 110 and 36 is basically 146. So the probability that they will score the same points or the sum is same is equal to 146 by 1296. Now in order to calculate x, I need to subtract this from 1. So this becomes 1296 minus 146 by 1296. This is 0, this is 5, this is 1, this is 1, divided by 1296. And I think this needs to be divided by 2 also. I forgot this 2, I'm sorry. So you can divide this by 2 also. So you will get 575 by 1296. And this is the answer that you're looking forward to. So let me divide this by 2 also so that you guys don't get confused. So again, a question which is based on your understanding. If you would have tried this question by solving this the conventional way, although I'm taking a lot of amount of time in solving these questions because I want you to understand the thought process behind the question. In the exam, since I don't have to explain you or you guys don't have to explain it to anyone, you will only take like 1/5 or 1/6 of the time once you have understood the concept. Okay, so another interesting question. So let's move on to the next one. So pause the video and try this question, please. Pause the video and try this question. Okay, so the question is, six mobsters have arrived at the theater for the premiere of the film Good Buddies. One of the mobsters, Frankie, is an informer, and he's afraid that another member of his crew, Joey, is on to him. Frankie, wanting to keep Joey in his sight, insists upon standing behind Joey in line at the concession stand. How many ways can six arrange themselves in a line such that Frankie's requirement is satisfied? Alright. So we want to ensure we have to arrange them in a line. So we have 1, 2, 3, 4, 5, 6. So Frankie insists on standing behind Joey. So if Joey is at the first position, then Frankie wants to be at the second position, or probably third position, or probably fourth position, or probably fifth position, or probably sixth position. It's not, the question is not saying that the Frankie wants to be immediately behind Joey. They're simply saying that Frankie wants to be behind Joey. That's it. Nothing else. Okay, now let's say one way of solving this question is we figure out all the cases. That is, first possibility that we can have is, so Frankie insists upon standing behind Joey. So we have Joey at the first place, which means Frankie will have 5 more places, or exactly 5 places to stand so that he's behind Joey. If Joey is at the second place, then Frankie will have 4 places, that is 3, 4, 5 and 6. If Joey is at the third place, then Frankie will have 3 places. If Joey is at the fourth place, then Frankie will have 2 places. And if Joey is at the fifth place, then the only place for Frankie is position number 6. Now apart from this, there is you can say there is no other condition on the remaining crew members, so all 4 of them can be arranged in any manner possible, which means those 4 people can be arranged in 4 factorial ways, because we have 4 positions, we have 4 people, so we can simply arrange them in 4 factorial ways. So we can say that the total number of ways will be equal to 5 plus 4 plus 3 plus 2 plus 1 multiplied by 4 factorial. So that will simply be equal to 15 into 4 factorial. So that is 15 into 24, and that's 360 possibilities. That's it. Now this is one way of solving the question where you basically annotate all the possibilities, like in which all possibilities Frankie will be behind Joey. Can I do this question without like annotating all the possibilities? Is there any other way around possible? Now I want to ensure that, let's say the another way of solving this question, I want to ensure that Frankie stands behind Joey. I have 6 positions. Let's only talk about Frankie and Joey, because for the remaining 4 members we don't have any conditions, so we, for whatever 4 places we are left with, we can simply arrange them in 4 factorial ways. The only thing that I'm concerned with is the condition, that is the Frankie who wants to keep Joey in his sight insists upon standing behind Joey. So if I have 6 positions and if I want to pick 2 positions for these 2 gentlemen, can I say I can basically do it in simply in 62 ways? You pick any 2 positions, whichever 2 positions you want. And I'm not planning on arranging them. After picking up 2 positions for Frankie and Joey, I am not planning on arranging them. Why? Because I want Frankie to keep Joey in his sight. That is, no matter what position I pick, I would always want Frankie to keep Joey in his sight. That means it's always J before F, or J always come before F. So there is only one order, that is J before F, or it's JF in the increasing order. It's always J before F. So we are not taking permutation into consideration. I can simply do 62, pick up any two positions. The front position will always be Joey, the behind position will always be Frankie. That is simply 62. What is 62? 62 is 15. Or if you want to solve it, is 6 factorial by 4 factorial into 2 factorial. That is 5 into 6 divided by 1 into 2, and that is simply equal to how much? That is simply equal to 15. And for the remaining 4 positions, the total number of ways in which you can arrange them is 4 factorial. That is again 15 into 24, which is equal to 360. If you don't want to make up the cases, then this is the another way around in order to solve this question. Right, so these were basically the 5 questions which we we were supposed to solve in this video. So I believe you have understood the approach of solving questions like these, right? What matters actually in questions of PnC and permutation and combination is that how do you approach a particular question. It is not about like whether you know PnC or no. Everyone knows what P stands for, what C stands for. Or if you don't, then you can simply type Binge's Education SAT plus GMAT plus GRE on YouTube. Go to the playlist and start learning about PnC and probability in detail. But what actually matters is how do you approach these questions? Once you know the concept, how do you read these questions? How do you apply your logic? That's the point. That is something which you need to understand. All right. So thank you so much, guys. So I'll be making one more video, which will be a continuation of this. We'll be discussing 5 more questions, which are good level questions for permutation and combination. Okay. So subscribe to the channel, guys, if you haven't, for more videos and exam related content on SAT, GMAT and GRE. If you have any questions, if you have any concerns, please, you can connect with us anytime. You can mail us, you can drop it in a WhatsApp, you can also drop in your text on YouTube chats, and if you're looking for any personalized classes for SAT, GMAT and GRE, you can always connect with us. Okay, so thank you so much. Keep watching and keep learning. Thank you guys so much.